Hello friends, welcome you all IAS with Arihant and very good afternoon to everyone. Now, let's join the all aspirants class, and those aspirants who do not subscribe the channel yet, subscribe the channel and share and like the class. Also, hit the bell icon to get the notification on time. So, if you are preparing for UPSC exams and state prelims exam, you must have this book. If you do not purchase yet, going to the market and purchase this book, or also this book available on the online platform, so you can buy easily on the online platform. This book, why is so necessary? Because this book really having a amazing content and 300 plus solved papers. So this book contains many features like chapter-wise, topic-wise division, topical mind map, 100% error-free explanation, knowledge plus for typical questions, and 3500 plus PYQs bullets. So, if you are interested and qualifying your UPSC prelims and state PCS in first attempt, so you must have this book, right? Now, let's start. Our today's topic is forces and types of forces. This is the second topic of Unit 2, Mechanics, force and types of forces. Now the question arises, what is force? What is force? Force is an external object agent capable of changing a body's state of rest or motion. It has a magnitude and direction also. When we are talking about force have both the values magnitude and direction. And direction. See, a push or pull of an object, product of mass and acceleration. Force formula is mass into acceleration, and its unit, when we are comes to its unit, is, and also we are going to discuss its dimension. Then the force dimension is mlt minus 2. It's the fourth dimension. And when we are talking about units in MK system is Newton. Force unit is Newton. In CGS system, force unit is dyne, and 1 Newton is equal to 10 to the power 5 dyne, and 1 gram weight is equal to 980 dyne, right? So now how can you calculate the units? See, SI unit of force, SI unit of force is equal to F is equal to M into A, mass into acceleration. Mass unit is kilogram and acceleration unit is meter per second square, right? Meter per second square. And when we calculate it, so both the unit becomes what? Its SI unit of force is Newton, right? In CGS system, how do we calculate this? In CGS system, how do we calculate the force unit? Gram into centimeter upon second square. Gram into centimeter upon second square becomes the unit of force dyne, right? It's now Newton. How dyne is come? Newton is equal to kilogram into meter per second square. Newton is equal to, this unit becomes 10 to the power 3 gram 10 to the power 2 centimeter upon second square, and dyne comes 10 to the power is equal to 10 to the power 5 dyne. See, how do we calculate the down? From this only, from this method only, right? Now comes to the topic, types of forces. Forces having types like balanced force, unbalanced force, balanced force and unbalanced force, and unbalanced force, and also it is further divided into contact force, friction, non-contact force, like this. Now first we are going to understand what is balanced force and what are the example of the balanced force, right? Okay, before that, before we going to understand balanced force and types of forces, you must understand the force has different effects. Like force can make a body is at rest to move. If some body is at rest, if some body is at rest to move, when we apply external force to any body who is at rest is going to be move, right? Okay, right here some points, like if can stop a moving body or slow it down. If it can stop a moving body or slow it down by applying external force on it. Second point, different effects of force. It can accelerate the speed of a moving body. It can accelerated the speed of moving body, right? Now the next point is, it can also change the direction of a moving body. It can also change the direction of moving body, and body along with its shape, along with its shape and size. These are the some effects of force on it, right? That is, force is equal to mass into acceleration. Clear? Now we are going to understand balanced force first. Types of the forces. Balanced force. What is balanced force? Balanced force are those that are equal in magnitude but opposite in direction. That are equal in magnitude but opposite in direction. In directions, right? And the net force applying on it is 0. The net force is 0. There are some examples of balanced force, like, what are the some examples of balanced force? Like resting against a ball, resting against a wall. Another example of balanced force is lying down. Lying down. If you are lying down to the surface is the best example of balanced force. Why? Because they are that are having a equal magnitude but in opposite direction, and the net force becomes 0, right? Floating in water, floating in water, also standing in ground, are some of example of balanced force. Clear? When the net force on the body is 0, example, a book resting on a table, lying down, resting against a ball, floating in water, standing in ground, are some of the examples of balanced force. Clear? Now comes to the next force is unbalanced force. Unbalanced force. What is unbalanced force? Unbalanced force. Unbalanced force are those force that are not equal in magnitude and may or may not act in the same direction, right? That are not equal in magnitude and may or may not act in the same direction. Act in the same direction. Am I audible and visible to everyone? Am I audible and visible to everyone or not? All right. Everything is clear. Now, what are some examples of unbalanced force? Unbalanced force. See, some examples of these examples are based in your daily life, right? These are the daily life examples, like a group of kids winning a tug of war game. Clear? A group of kids winning a tug of war game. This is unbalanced force. Like one group of kids stand at the A point and just stretching the rope. Other side of group of kids just stretching the rope this side, and this type of group stretching the rope this side, right? Like this. Some people are standing over this position and stretching. Only one group of kids winning this tug of war game because they exert a heavy force on their side. Clear? Now, the second example is a car accelerating, braking, or turning. A car accelerating, braking, or turning. It is the example of unbalanced force, right? An object sinking in water. An object sinking in water. That is unbalanced force. Why? Because they really do not have a equal magnitude and may or may not act in the same direction. That is why it's going to be happen. Also, riding a skateboard, another example of unbalanced force, right? Now, now unbalanced force. Another type of force is contact force. Contact force is by the virtue of bodies in contact. Also, there are many types of contact forces like frictional force, torque force, tension force, normal force, air resistance, applied force, and spring force. You can note down all these forces right here. Tension force. These are the subtypes of contact forces. Clear? Normal force. Also, air resistance force. Air resistance force. Friction force. Friction force. Also, applied force. Applied force. Spring force. Spring force. Contact force having the virtue of bodies in the contact, and these are the some subtypes of the contact forces. Clear? Now first we are going to study the friction force. Friction force. Again, friction force. When we are talking about friction force, what is friction force? See, there are 4 types of friction force. Friction force also further divided in many types like fluid friction, rolling friction, sliding friction, and static friction. Static friction and greasy friction. Also you can add here greasy friction, greasy friction, kinetic friction or a friction also known as dynamic friction, also known as it is dynamic friction. Dynamic friction. Clear? Now what is kinetic friction? Now what is kinetic friction? Frictionless force which acts between the moving objects. Frictional force which acts between the moving objects like sliding friction, rolling friction. Also kinetic friction further divided into 2 parts, sliding friction and rolling friction. Sliding friction, frictional force due to the sliding of one body over the other. All right. And rolling friction is frictional force due to the rolling one of body over the other. Right? Now come here and understand. We take a next page, a clear page, and understand what are the types of friction forces. See, come. First type we understand, that is static friction. That is static friction. What is static friction? The magnitude of the static force is equal to the opposite direction when a small amount of force is applied. Right? That is called a static friction. And what are some examples of static friction? Sliding of the block across the floor. Sliding of the block across the road like this. This is the block sliding across the road, point A to B. Clear? Another example of this static friction, 2 cords sliding against each other in a deck. 2 cards sliding against the each other in deck. If you are playing a cards, if you are going to playing a cards, right, you having a deck in your hand and you shuffle the cards, so they are they are sliding against to each other in the deck. Clear? Right. Now the second friction force is sliding friction. Right? What is, oh, okay. Static friction. All right, just change it here. This is the examples of sliding friction. Okay. Now, static friction. Sliding friction is resistance that is created by only or any two objects when they are sliding against each other, and the static friction, the magnitude of the static force is equal in the opposite direction when a small amount of force is applied. Right? Now, what are the examples of static friction? Static friction, some examples are skiing against the snow. Skiing against the snow. This is the example of static friction. Another example of static friction is creating creating heat by rubbing both the hands together. Creating heat by rubbing both the hands together. This is static friction. Table lamp resting on the table. Table lamp resting on the table. Clear? Sliding friction, static friction, and next friction is rolling friction. Rolling friction. What is rolling friction? Rolling friction which resists the motion of a ball or wheel, and it is the weakest friction or weakest type of friction. Clear? It resists the motion of a ball or a wheel, motion of a ball or a wheel, and it is the weakest types of friction. Clear? What are the some examples of rolling? Rolling of the log on the ground. Rolling of the log on the ground. Next point is wheels of the moving vehicles. Wheels of the moving vehicles. Right? Also some stone rolling down towards the ground. Right? All these are the examples of rolling friction. Rolling friction. Clear? So, now limiting friction. Clearly, what are the limiting friction? You understand by limiting friction, maximum value of static friction. Maximum value of static friction. See, when we discuss limiting friction, another type of friction force, it is friction created when two static surfaces come into contact with each other. Limiting friction created when two static surfaces comes into contact contact with each other. And what are some examples of limiting frictions? The limiting friction between your shoes and the floor keeps you free. The limiting friction between your shoes and floor keeps you free slipping when you walk on the floor. Keeps you free when you walking on the floor. Clear? This is called limiting friction. Now comes to the next point, non-contact. Okay. When we understand contact forces, also we need to understand non-contact forces. There are many types of non-contact forces like magnetic force, electrostatic force and gravitational force. Force which can be applied without a physical contact with the object known as non-contact force. Clear? Gravitation force, also you can add here electrostatic force. Clear? Also you can add here magnetic force. Magnetic force, right? And what is the magnetic force? If we bring a magnet, see, understand, magnetic force, friction, magnetic force or magnetic friction, it is a type of non-contact force. Clear? If we bring a magnet near an iron nail, then the magnet pulls them towards it since magnet exert force. Clear? See here, like this is the magnet. This is the magnet and this is the nail. This is the nail. If we bring a magnet near an iron nail, this is the iron nail. This is the magnet. And if we bring a magnet near an iron nail, then the magnet pulls them towards it since it exerts a force. Right? So this is a non-contact force. Without contacting each other, it pulls or exert a force towards the magnet. Clear? Now, electrostatic magnet, electrostatic force. How we understand this? When a plastic comb is rubbed in dry hair, then the electrically charged comb attracts a tiny piece of paper. Many of you aspirants did this experiment in their school times. In school times, when we were in a school, many teachers perform this experiment. Right? So this is also you can perform in your home. If you are free, you can definitely do this experiment. Clear? Another force is gravitational force. Gravitational force. Clear? The force of attraction between the earth and any object. The force between the earth and any object is called the force of gravity. Clear? Is called the force of gravity. Without contacting each other, they can attract to each other. known as gravitational force is a part of non-contact force. Clear? Right? So I hope you understand all these points given here. Now we are going to discuss some question based on this theory part. All right. Yes, again, force in force in uniform circular motion. This is a most important topic, and all the aspirants who are prepared for the UPSC and state PCS exams, or they do not have this book yet, you can purchase this book. This book really having a good content, and also having important facts, bullets points, knowledge plus, right? So you can have this book and boost your preparation for your upcoming prelims, UPSC and state PCS examination. Clear? And you can share this class with those students who are interested and preparing upcoming UPSC and prelims exams. Hello everyone, right? And also you can hit the bell icon, and those aspirants who do not subscribe the channel yet, subscribe this. Now comes to the force in uniform circular motion. There are two types of circular motion. First we call it centripetal force, and second is centrifugal force. What is centripetal force? What is centripetal force? How can you define the centripetal force? Tell me. See, if any body or force which acts in circular motion directed towards the center of circular paths. If any body moving in a circular path, and if its force exerts it towards the center, known as a centripetal force. Centripetal force. Right? Also, the centripetal force is two-dimensional and having a uniform speed. This is two-dimensional force and having a uniform speed, and in this circular path direction, and in this circular path the direction is changing direction. You notice change in direction every point, right? In this you experience or you realize change in direction of the object at every and each point. Change in direction of object each and every point. Right? So the example of centripetal force, F is equal to mv square upon r. R is the radius. R stand for radius, m stand for mass, and v square is equal to velocity of the object. Clear? Now they are giving some example, and electrons revolving around the nucleus. An electron, you know the diagram of atom. This is atom. This is the center where proton and neutrons are there, right? And they are shells of any atom. This is nucleus part in which proton and neutrons are present, and electrons always lying in the outer shells of atom, and they revolving around the nucleus, right? So this is the example of centripetal force. Another example of centripetal force which based on our daily life, like a car driving with constant speed, like a car driving with a constant speed, clear, around a circular race court. around a circular race track. All right. Another example of centripetal force, the constant speed of motion of the carnival ride, merry-go-round or rotating ball. Rotating ball. Rotating ball. Merry-go-round. Carnival ride. All these are the examples of centripetal force. Clear? Now, centrifugal force, centrifugal force. Centrifugal force is a pseudo force in a circular motion, right? Is a pseudo force in a circular motion which acts as along the radius. Also, it is directed away from the center of the circle. It directed away from the center of the circle. Center of the circle, right? Apparent force of an object, force acting outwards to the center of the circular path. They given an example, machine for extracting butter from milk. This is the example of centrifugal force, machine for extracting butter from milk. Another example of when the engine spins fast enough. When the engine spins fast enough. This is the example of centrifugal force. Weight of an object at the poles and on the equator. Another example of weight of the object on the poles or on the equator, right? A bike making a turn. Suppose that a bike is in a circular path and then suddenly it's making a turn like this, right? So it's away from the center. It's away from this center. The bike rider. Clear? So this is the example of centrifugal force and equatorial railway. Clear? All these are the examples of centrifugal force and centripetal force. I hope you understand this part. Clear? Now comes to the question answer. Number one question is, a batsman hits a cricket ball which then rolls on a level ground. After covering a short distance, the ball comes to the rest. The ball slows to the stop because the batsman did not hit the ball hard enough. Velocity is proportional to the force exerted on the ball. There is a force on the ball opposing the motion, and there is no unbalanced force on the ball, so the ball would try to come to the rest. Now tell me, which one is the right answer? See, the correct answer is, there is a force on the ball opposing the motion, and which force opposing the motion is friction. We called it as friction force. This work done by friction force. This work done by friction force. Friction force, right? If you are moving towards this way, friction force applying towards your opposite direction. Clear? Opposite direction, right? This is like friction force work. A batsman hits a cricket ball which then rolls on a level ground after covering a short distance. See, there is any batsman like this playing a cricket, having a bat. Having a bat like this, a ball's through like here, and he hit the ball and ball rolling down over the surface like this, right? This is the surface, and gradually and it becomes like slow motion. It becomes in a slow motion. So the ball comes to the rest, the ball slows down to the stop because there is a force on the ball opposing the motion called friction force. Clear? Next question. It is difficult to walk on the ice than on the road because. Why is it so difficult to moving along the very, smooth path, but we are very comfortable moving on a rough path? Because of the friction. Friction works best on the rough path. When we are walking on the road, it is very easy to us easily walk on the road, but when we're talking about walk on the ice or a snow, it is really hard. Why? Because ice is harder than the road. Wrong answer. Road is harder than the ice. Wrong one. Ice does not offer any reaction when we push it with our foot. Another wrong one. Option number D, ice has a lesser friction than the road. It is because the friction force. Clear? Ice has a lesser friction than the road. The working principle of a washing machine. 1 second. Okay. Okay, this one. It is difficult to walk on the ice than on the road because ice has a lesser friction than the road. There is no friction between the bottom of our feet and the ice. Hence, it is difficult to walk on it. The roughness of the surface of the road helps us to move forward on the road. This is because of the friction. Next question, question number 3rd. When the two surfaces in contact have a very thin layer of the lubricant in between them, it is known as solid friction, rolling friction, film friction, or greasy friction. Which one will be the right answer here? Okay. 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 Now, right answer is greasy friction. Greasy friction, also known as bound friction or boundary friction, right? Also known as boundary friction, or non-viscous friction. The working principle of a washing machine is Again, this is the wrong explanation of the question. When two surfaces in contact have a very thin layer of lubricant in between them, then it is known as greasy friction. Greasy friction is also known as boundary friction or non-viscous friction. Greasy friction is produced when two surfaces are wetted with an extremely thin layer of lubricant and metal to metal contact, right? Next question comes here. Consider the following statements. A four-wheel vehicle moving a sharp circular path at high speed will overturn about its outer wheels, overturn about its inner wheel, skid outwards, or skid inwards. Which one will be the right option? 1 and 3, 2 and 4, 2 and 3, and 1 and 4. Okay. If a four-wheeler moving around a sharp circular path like this, a car moving around a circular path, a car moving around this circular path, right, like this in a circular path with a very high speed, it overturns about its outer wheels, about its inner wheel, skid outwards or skid inwards, right? So overturn about its inner wheel and skid inwards is called as, it happens in the centripetal force. It going to be happen in the centripetal force, right? Centripetal force. But overturn about its outer wheels and skid outerwards first and third, it shows centrifugal force. Clear? So option number A and third is the right answer. The working principle of a washing machine is again. Okay, this is the right example. When a four-wheel vehicle is moving at a speed higher than the maximum permissible speed, it tends to skid outwards at the turn and overturn about its outer wheels due to centrifugal force, right? In case of vehicle moving along a circular path, two types of forces, right? That is centripetal and centrifugal in centrifugal motion or a path, the object comes away from the center, and in the centripetal force, the object towards the center, right? In case of vehicle moving along a circular path, two types of forces, that is centripetal and centrifugal, acts upon it as they have opposite impact, thus the object remain in balance. If car takes a turns as circular path with a higher speed, then force of friction available between the tires and the road is not able to provide the necessary centripetal force. Why? Because the higher speed of the car. Clear? Hence, due to centrifugal force, vehicle will leave the balance and will skid in the outward direction of outer wheels. Clear? Hello Avinash. Now comes to the next question. Question number 5. Consider the following statement and conclusions which can be drawn from it. Choose the correct conclusion. Statement is, in starting a loaded cart, one has to push harder than to keep it moving. If we are going to starting a loaded cart, this is the loaded cart, right? There are so much stuff in this cart, and someone has to put harder to start this cart, right? Someone has to push so much harder to start this cart. Why is it so? The weight of a moving object is less. See, this has so much weight. Assume it has 100 kilogram. Right, the wheels tend to slip initially. The cart wheels tends to slip initially. There is less friction once the cart start moving. Practice makes perfect. This is not the correct answer. See, this is the cart, loaded cart or a full of stuff and having so much weight in it. So someone has to push hard to start this cart, right? Why? Because there is less friction, and once it starts moving, it comes in the motion. Option number C will be the right answer. Clear? In starting a loaded cart, has to push harder than to keep it moving, because there is less friction once the cart start moving. The reason is that to move a loaded cart before started, it is at rest. Where is it at rest? And the body, when the body or any object is at rest or in a motion, it denied or resist the static friction. Clear? Or applying any external force in it. Why? Because it is due to inertia. It is due to inertia. If any object is at rest, it remains want to rest, right? Work has to be done against static friction, whereas to keep a moving cart in motion, work has to be done against kinetic friction. The static friction that holds the body in a place is greater than the kinetic friction down a moving object. That is, when the body starts moving, then kinetic friction decreases from static friction. Clear? Now comes to the next question. Question number 6. Cycle and cars used ball bearing because the actual area of contact between the wheel and axle is increased. The effective area of contact between the wheel and axle is increased. The effective area of contact between the wheel and the axle is reduced. And none of the above statement is correct. Right? What is the right answer of the question number 6? Cycle and cars used ball bearing because, tell me, because the effective area of contact between the wheel and axle is reduced. Cycles and cars used ball bearing because the effective area of contact between the wheel and the axle is reduced. The purpose of a ball bearing is to reduce rotational friction and support radial and axial loads. Right? Comes to the next question. Question number 7. A person is sitting in a car which is at rest. The reaction from the road at each of the 4 wheels of the car is R. When the car turns on a straight level road, how will the reaction at either of the front wheels vary? It will be greater than R, it will be less than R, it will be equal to R, or it shall depend on the material of the road. Material of the road. Hello Prashant, hello everyone, hello. Okay, so question number 7 is your homework question. We will discuss this question in the tomorrow class. Alright. All the students who are coming late in the class are requested to join the class at the time. And the class time is 12 p.m. Right? So if you are preparing for UPSC and state PCS prelims, and if you want to qualify the exam at your first attempt, then you must have this book. If you do not have this book, purchase this book now. It is available in the market and also available on the online platform. This is the book by Arihant, Prelims Possible, Pehli Baar mein Prelims Par, right? They also have so many variations like they really have Indian history, geography, Indian geography, world geography, Indian polity, Indian economy, and general science. And this book, and this is the book of general science, right? Prelims possible having 300 plus solved MCQs, and they have 100% error free detailed explanation, knowledge plus with typical questions, PYQs bullet for revision, and free package chapter test. Clear? So those who are not purchased yet, they can must purchase this book, because this book really having a good content. And those students who do not subscribe the channel yet, subscribe the channel. Also share this class with your relatives one, and those aspirants who are going to prepare the UPSC prelims and state PCS. Thank you so much. We will continue this class by tomorrow.